I believe this is mandatory for any computer engineer. Let me see. I'm just trying to find the chat here. I don't know yet how to configure. hmm Open chat. Okay. Yep. Okay. So we have here wrapping up the chess game. I haven't it's have been a busy week. I couldn't make the progress that I was planning to on this game. So, but I'm very close to have the board already finished. Let me show you though. Let me show you. So I want to emulate the same board of the chess.com, kind of. I'm not going to include all the functionalities because it would be a lot of time consuming for this type of project. I have another project to kill and to finish uh, this month that are more important than this one. This is just for fun, so I can remember a little bit of C++ and SDL. Um, so yeah, so ask anything, guys. I hope you stay here. Ask anything. Um, I want to talk to you about a specific thread on computers on quantitative finance because I believe is man, this is a topic that I have done the most of my research. I spent like 5 years just researching this. I'm very I'm not a quantitative trader, okay? I'm just a computer scientist that I like to research things deeply when I'm interested. And this is was one of the one that I was interested for many years. I am interested. Um, I want to show you a specific thread this week because I believe it holds a lot of value. Okay, and it's for these guys, Darren. Let me see if I can show you here. Okay, we have here, and the main pinned thread that he has here is a very unique thread that I believe everyone should read. Even if you don't want to become a quantitative trader, you will learn. Hey Vicenzo. Hey man, thanks for the question. So Vicenzo asked how to start learning programming. Very silly question, but I really know nothing about it. Hey man, it's not a silly question. Any question has some value, mostly for the person who asked it. I believe there is a lot of value just doing picking some programming languages that you are interested and start doing projects. Use AI, use YouTube, use Google, and do projects one by one, one by one, and finish it. Scope the project. This is what I'm going to do. I'm going to use, I believe that you should start using Python. Python will expose you to different knowledges, not only on the programming side, but also on OOP, which is object-oriented programming, and also you can use this Python. It's a very versatile language, so you can use it in many things. You can use it for data analysis, for AI. You can use it for web applications. You can use it for um, Pygame. You can use Pygame, which is just a wrapper of SDL library to make games. You can use have fun. Um, every time that I want to review something on the technical side related with specific languages, I'm going back and I try to make some game. That's what I'm doing right now. This type of videos because I was getting a little bit rusty on C++. It's been many years without coding in C++. And I say, okay, I'm going to review C++ and I'm going to do some games there. It's fun. got it? Oh, you're welcome, man. Select one languages, I would say Python, and start doing projects. Have fun. And if you start doing mini games, simple games, you will have more fun and you will be exposed to a lot of specific concepts on computer science, programming, and data, um, data structures. You will be exposed to a lot of knowledge. If you don't know those specific knowledge, so you just go Google it and learn it, take some notes, you review every in a weekly basis. So where we are, okay, I want to talk to you about this post because I believe it's one of the most important threads that I ever save here. If you are a quantitative guy, so if you are a programmer that want to learn quantitative finance, I believe this is a mandatory post. Darren has here is a thread of threads. So you basically have a thread that has more threads with more details in it. Okay, let me show you here. So Fortune Formula is a mandatory book for all of those that want to understand risk. Okay, this guy is amazing. He has posted all his research here on Twitter. Okay, I'm not sure. Oh my gosh, I just went back. Okay, so I'm not sure if I should read this one, um, because yeah, let's read it a little bit. If you have some interesting if you are interested in any specific subthread, we will go deeper. But I want to review this one with you right now. So how do you maximize compound return? So this is a very important question, and it's one of the most, it is one of the principal questions that every trader asks. Actually, I'm not sure about that, but it's a very important question. And the reason I'm not sure about why traders don't ask this question is because they believe that the way to maximize returns is just adding more risk in each trade, which is not the case. Okay, here are the five main uh, principles that he exposed here in the first thread. So if you want to maximize compound returns, you shouldn't use too much risk. Okay, you shouldn't rely on bounce backs. You shouldn't take appropriate risk depend on the expenditure ratio of the strategy you are using. You should also uh, be aware that the only free lunch is when you use in investing is when you use diversifications. Okay, you need to diversify the systems you trade. You need to diversify in many ways. There are many areas to diversification, but basically you need to diversify on the systems, on the specific instruments you trade, and you need to um, you need to also trade long term, short term, different strategies, different premiums. You should aim to get different premiums from the market. So that's what he is saying here. And hedge the relevant tail. Basically, you need to hedge your most. You need to be prepared to hedge when something doesn't go as you think it will go. Okay. So rule number one is never lose money. Okay. Fortune formula. I have this book here in my bag. I read this. This is for William Poundstone. It's a very important book, and I believe you should read it if you want to understand trading before you even start trading. Actually, so too much risk turn a positive average return into a negative compound return. A stock that's up 100% 1 year and down 50% the next year has an average return of 25% a year, but compound return growth is this CARC of 0%. So the reason I believe he put this in the second option is because you need to understand how CARCs CAGR plays a role on your trading systems, okay, on your component. So, and the reason he made this specific is a specific, I believe this specific sentence here is because most people, when they get good returns, they double down on those things, thinking that they're gonna get more, and they end losing everything. Okay, so there is a more specific, deep subthread here about this one that maybe we will go over each of them in a, because this is a very important topic, in my opinion. Okay, it will expose you, even though you don't want to become a quantitative trader. I believe that it will expose you. The reason I like this topic is because is it was exposed to me to many other concepts that I wasn't aware of. Okay, I wasn't aware of all the concepts that quantitative finance research gave to my tool set, my reasoning. Okay, and I got hooked. I got hooked here. That's the truth. So with leverage, the account goes to zero. So 2-to-1 leverage. So he's just mentioning the importance of leverage here and the relation between leverage and CARCs, depending of some specific systems. Okay, uh, four, if we assume that stocks move randomly, compound return, average return is a half times volatility squared. For return about short-term interest rate, average return is equal to Cherp ratio volatility. Cherp ratio is just a way to measure returns, okay, that has risk embedded on this specific ratio, okay. So basically, he's just giving you a compound return here equation, which is which include risk, include really includes risk, which is very important. The reason that I'm telling you this is because most people say, "Hey, I made last year 25%, 100%," but they don't know how much risk they took in that specific um, year. Okay, let's see. We have another important here. We have the difference between. Yeah, he continues explaining here about leverage. He talked about real estate, and this is where things get a little bit weird. Um, for real estate, global index historical had a average excess return of 6.07, okay, with volatility of 9.86. Most people own one house, not diversified global index, so CARS is lower. So here, this thread is more about the housing returns um, for the average people, the average guy that only holds one, one single family home. He also, oh, this thread here about the housing bubbles, and also I believe this thread is the one that he has the book Underwater. Let me see. Uh, what is it? Oh, the wealthy renter. Okay, this is a book. I haven't read this book, but I took some notes on and did some research on the book. I didn't read it completely, but it seems that very interesting. When you hold information, when you receive the information about this, you will think differently, and you will approach your life different when buying and renting a house. Okay, and this is what I like this um, about this type of information, because it helps you reasoning differently. Okay, if we have money set aside to make payments, even if our equity goes negative, we are really not leveraged 5-to-1. We are using human capital or income from a job to feed an underwater property, which is a lot of people are in this situation. It's still an expensive down to recover from, though. Yeah. Bounce back. Here's playing why in bounce. You shouldn't rely on bounce back. Basically, what it's saying is that if you are implementing a system, okay, and these systems go, you make, like, say 25% this month, and the next month you are going to, you're making, let's say, minus 30%. You are under the water 5%, right? So most people, when they have this situation, they say that they are in a, how I say it, they are in a red period. In the traders said that they are in the red period, which basically is just um, under the water. Okay, on on your on your gains, and most people believe me or not, and for some specific biases that I'm going to speak in a different video, start talking and start adding to this specific situation to the systems, to the system, to the stock. So if you go down, you believe there's going that is have to go up again, and you just or maybe the reasoning you add is because the stock is just cheaper, okay, which is not always the case, okay. And yeah, most people relies on this type of strategies, and that's why the marketplace is crazy. It's crazy out there. Let me see what other thread I have here. Oh, this one is very important. Is explaining the Kelly bet formula, which is just a way to find the best way to position your size for each bet. I really enjoy this specific thread, and let me see if I have. Okay, okay, Kelly. This thread is amazing. I really like it. I'm not gonna dive deeper today on this one. I'm just waiting for some specific questions to see if someone appears here. Um, it's important you use the Kelly in order to calculate the size bet, and understanding the share value of your system is the one that help you to configure the Kelly proportion of your bets, right? So it's a very important quantitative finance formula that every trader should understand, and most traders don't use it. They use it maybe. I have seen a lot of discretionary traders just splitting the size of the bets depending of how well they are doing. Many traders do a lot of use different strategies, but this is one of the best way um, to use it quantitatively. The problem for discretionary traders, at least for what I'm seeing from my reasoning, is that um, most people or most traders don't even know the share value of their system they are running. I mean, except you are a quantitative trader, of course. Oh, let me close this here. Man, this trade is insane. Let me see what other specific. Oh, this one, leverage trading by. I believe this is the most important book. Well, this is not the most important. It's the second most important book that every trader should read. And I have all of them here. I'm going to show you a different. I want to make a different. Oh, if you know, if you are interested on this topic, just let me know if you want a specific video for these books, because this book are from Rob Carver. I choose Rob Carver as my mentor when I was researching this topic. Okay, I bought all of the books he just wrote, and I read each of them, and I studied very hard each of them. And I believe every trader should get the information before any trade on systematic trading and leverage trading. The main was the two main books that they have about systematic trading. Okay, he has another related Rob cover. I think is okay. Let's go to the systematic block. This is an insane block. This guy is amazing. He has done such a great work on quantitative finance. Uh, Let me show you the books. Okay, so he has systematic trading. He has also smart portfolio, leverage trading, and advanced future. I don't have this one yet. I have to buy this one. I want to review this one. Okay, so systematic trading was the first book he wrote. He created a system. He created a system and a framework so you can use his system depending on the type of trader you want to become. If you want to be a long term or medium term or a systematic trader or just a discretionary trader. So he exposed you how to create your own framework depending of this decision that you have to make, the market that you want to make, the trading account, the broker that you have to choose. And this is a very It's a simple book because it doesn't include any math actually. Um, I mean, I read in one of his interview that was done that way on purpose so they can sell more books and most people understand what he's saying. Um, a smart portfolio is just a practical guide to building and maintaining intelligent investment portfolio. This is just a way of investing. I think this was written for more professional managers. Okay, I have that one, this one too, but I haven't read this one deeply. I read this one, leverage trading, which was a very other basic book that I believe is just cover things that were he didn't touch in systematic trading. And I have to read this one. I'm not sure how good at this one, but it should be very good. He also had another. Let me see. So Pi System Trade, which is just his own framework, his own systematic framework in Python. Okay, you should take a look at this one and do some research. He basically have his own system that the system that he is running here in GitHub. This is incredible, guys. You can't believe this guy handled billions of dollars in his hedge fund. He's already retired from the professional trading side, but this guy is amazing. I think he's a very smart guy and he is playing very well his knowledge. He's very good explaining what he knows, and he put a lot of work on the things he said he's going to do. So, if you want to start doing quantitative finance, I believe this is another point of research that you should go. And I told you this one is the third one. Okay, you should go. You should start here with Darren. I believe you should start here with with Rob Block. You should go with Darren after. Read all his threads, okay? And he has a lot of research here exposed here. He seems to be a very smart guy too, okay? And after that, you can get this systematic Python framework, and you should see how he does, how he implement what he says he's going to do on he wrote on the books, okay? Okay, what else? Let me see if I can see something here. He's just talking about Monte Carlo, mm-mm-mm. About books. Okay, let me see if we have some books here that I already. Oh, he had different threads about books. I have many of them myself because I really like this. Let me see if I can find the other. Oh, this is another guy that has another specific. But this is not only from quantitative finance. This he writes about trading, about specific concepts, and he seems to write very well too. So you see, he is just explaining the Gambit arena, which is just a probability theory. He seems to know a lot of about math, statistics, and probability. So and he tried to add the investment explanations with this type of concept. He merged this type of concept, which I believe is insane. So this is another point of resource to do research. Okay. What else? What else? I give you Darren. I give you. Okay, this is on quant finance. Let me see what else I have here. Uh, okay. Mm-mm. Market. Okay. Okay. Let's review the week. Okay, this week I researched several ideas. Okay, um, I'm implementing the chess game on purpose just to have some fun with STL and C++. And I had to remember when to use a pointer reference, a pointer versus a reference. Okay, this was the latest note that I just took few minutes back. Okay, it's important for you to understand how C++ work with pointers, pointer reference, and references. I also did some research on CUDAs programming. I believe this I haven't finished this conference yet, but as you can see, I'm around the half. But it's a good explanation on how CUDAs works. Okay, why? So the reason you are using GPU is for performance. You use CUDA to write performance code on GPU. Performance is limited by the law of physics. So CUDA is the way that it is because of physics. So he's explaining. I haven't finished this one yet, but basically he's explaining how the law of physics limit the GPU processing. It's not the GPU, it's the way I believe, if I remember correctly, is the way we get the data from um, from the RAM. So the limit is right there. So we have the reason you're using a GPU is for performance. It means using all the GPU resources that you can. What else we have here? The NVIDIA Ampere GPU architecture is just explaining also how NVIDIA, at least this one that we already know. We don't know that much about I mean, we know if you are an expert on this area, I suppose you have the information. I haven't found the information for the latest one. Okay, so what else we have here? So flops are not the issue. He's explaining the amount of flops per GPU core, and here we have he started explaining the memory bandwidth limitant that we have, and that's the, let's see, peak memory request rate. How he's explaining that the specific issue with the memory bandwidth. I haven't finished this, so I don't know. I haven't finished research this, so I don't want to talk deeply. But this is a good resource. I'm going to put this video maybe on my weekly close post. Okay, I want to start doing this on a weekly basis. So what else I researched this week? This is a good like tutorial for free you can find on CUDAs. It seems to be good though. It seems to be good. I just went over it and I just saved it there in order to understand it better. Okay. What else? Oh, I found a video that I keep here about the first object-oriented programming languages, which is this one. Let's see.
Single thesis ever done. A remarkable program in many ways, even today, as we'll see by looking at this tape. This tape is from the very first movie of Sketchpad, taken in the summer of 1962. So this is 25 years old.
1962.
Rubber bands you're familiar with, but look at what he's doing. He's pointing at the edges and saying, I want them to be all mutually perpendicular, and Sketchpad just figured out how to do that. Sketchpad is the first system to ever have a window. He's actually drawing on a virtual sheet of paper about 1/3 of a mile on a side. And again, to get something he wants, he simply sketches it in roughly and then gives rules like be parallel and perpendicular, and Sketchpad figures out and solves the problems. Here the rule is collinearity, so that the dashes lie directly over the guidelines below. Sketchpad was able to solve very complicated problems in real time involving both linear and nonlinear systems of constraints. So it was the first non-procedural programming system and considerably more powerful than the spreadsheets of today. So he's made a hole in the flange, continuously zooms back. Now he wants to make a rivet, and again we see why it's called Sketchpad. He just draws a rough shape, uses the center of the crossbar there as the center of the arc, and then points to the edges and says, I want these to be mutually perpendicular again. Solving that forces the crossbar to change, which forces the arc to change, which gives
That's
you
amazing.
a
That was 40 years back, guys.
And he shows that no matter how you distort it, when he turns the problem solver on, it will come up with a symmetrical solution. And he could have made it more complicated. He could have constrained the side lengths to be ratios of each other, or tied to some other drawing in the environment. Now, another important idea seen here for practically the first time is that of master drawings and instances. He was working on a master drawing, and what he has here now is an instance of that.
He has a control panel here. We can see the buttons, but it seems that he has also some input device here.
The instance can be rotated and scaled and positioned. So he's going to insert the rivet in the hole. By the way, the Sketchpad was the first system in which it was definitely discovered that the light pen is a very bad input device. So the blood runs out of your hand in about 20 seconds and leaves it numb. And in spite of that, it's been reinvented at least 90 times in the last 25 years. Here's another instance of the rivet, another one. Now, the display is jumping around like that because they didn't even really have computer displays back then. The TX2 is putting up every dot by brute force. He didn't like the cross pieces, so he goes to the master drawing, makes them transparent. Lo and behold, we see dynamically that the rivets, the instance rivets, have felt that change. So Sketchpad is also the first object-oriented software system. I once asked Ivan Sutherland, how could you possibly have done the first...
Do you hear that? It's the first object-oriented system, so it's deal with each figure as an object. It can be
interactive graphics program, the first non-procedural programming language, the first object-oriented software system all in 1 year. He said, well, I didn't know it was hard. There's nothing like this before. And here he's showing that every instance that you make of something, every master can create instances. So he's making a bunch of copies of the hole in the flat.
Nice. So, yeah, I think I thought that was a very cool video. So I made this question: C++ is all sufficient for complex software systems? Yes, this is a thread for Daniel, some PhD guy here, and he has this book or this PDF, Beyond Object Orientation, C++ Application Design for Computation Finance, a defined process from problem to parallel code. Yes, I indexed this PDF. This is in abstract. In this article, I'm not sure if you can read this. Okay. In this article, we introduce a defined and repeatable process to analyze, design, and implement software systems using a combination of techniques taken from structured analysis and the object-oriented programming style. We use top-down system decomposition and bottom-up programming techniques to create software systems. We also show how to leverage the new multi-paradigm features in C++ to promote maintainability and extendability of the result code, and how to integrate C++ multi-threading and multitasking libraries with our model. As an example, to reduce the scope, we introduce a model for Monte Carlo option pricing that we designed and realized using several different languages features in C++. the steps in the transformation from a problem description to code are applicable to other kinds of systems, for example, PDE and RISC application, as well as other programming languages, for example, C Sharp. This article represents a continuation of the work in Duffy and Pele, Wilmot, Lewis, and Duffy. Keywords, computational finance, Monte Carlo simulation, system decomposition, C++ 11, current and parallel problems, how to solve it, reasoning by analogy. Yeah, this seems to be a very good PDF. I'm not gonna read everything right now to you, um, but let's see what we have here. System scoping and initial decomposition, system context diagram. Okay, he just basically, okay, new context diagram from Monte Carlo engine. So he's trying to design with this specific structure. He's going to design the application. Dynamic polymorphism. Finding concurrency in applications. Step 2, parallelization. We have given an introduction to a defined and repeatable process to analyze and design mathematical problems in computation finance, and implementing it using a multi-paradigm programming style and new libraries that C++11 supports. The approach taken here is to understand the problem, then decompose the resulting system into subsystems, and finally design each subsystem. We postpone the choice of a traditional object-oriented design for as long as possible because it is kind of premature optimization. For readers who do not yet have hands-on experience with multi-threading, we recommend OpenMP as a good way to learn the basic principles from both a theoretical and practical perspective. Yeah, it seems to be a very interesting book. So I haven't read it, but here talk about context diagram, system decomposition, component black box interfaces, parallel data dependency graph, and using domain knowledge. Okay. What else we have? We have another kudas. I believe this one should go here. Okay. How to become a quant. This was it was a very basic introduction on how you can become a quant. The area of knowledge that you need to dominate in order to become a quant developer, a trader of a quant researcher. More complex than what to expect software engineer. This is all my training stuff. Making a better particle simulation in C++. Oh, I like this one. I have this one. I keep bookmark it.
Hello.
Because um, I think I think I'm going to at some point do this type of videos. So you need to understand particles, how particle behaves, and how to simulate particles when designing games. So yeah, I'm gonna move after I finish the chess game to do this type of to review this type of videos, simulating some type of specific physics stuff. Okay, GPU, we have Tukuda here. Okay, let's just close a little bit of this. What else we reviewed this week? Yeah, more about C++ and engine optimization. I also saved this one, which is related with C++, Doom engine architecture. Okay, this is a more specific video about, I don't remember what is this one. Oh, this wasn't a specific video that I saved for video game design. No, Timothy Kane. I found this guy. Um, I found this guy this week, which is basically the guy that designed. What's the game he designed? He's famous game designer, which I don't remember yet. What was the game he designed? Let me see if we can find it here. Oh, he was one of the game designer of Fallout. Okay, okay. And I found this video, the Wiz Wizard. It's a case study. I read this video. I researched this video completely. It's basically explain the simplicity of this game and how, even though this game was simple, it was a very powerful game that almost that has impacted his career. We'll put the links here so you can just. This is the game. This is the name. You can search also here. Okay, what else I found?